Hi there, students. Today we're going to learn about the Pythagorean theorem. This is a flip book that you should create, and you're going to go along and do the notes with me. Today in class we did an activity with surrounded by squares where we learned how we get the Pythagorean theorem, and now we're going to put it all together with some notes and examples. So this is your final product that you're going to want to have, but I'm going to show you with the handout that I gave you in class how you're going to put this together. So you got a handout like this. So the words are going to be on opposite sides. So the first thing that you're going to do is you're going to take and you're going to cut in the middle here to make two half sheets like this. And then you're going to follow the directions where it says cut this piece off. So you're going to cut all those pieces off. So I'm going to cut off this one. So like this. And then on this sheet, next to where it says vocabulary, I'm going to cut that. So basically you're just following the directions. You can cut that piece off as well. And then we're going to look on the other side. And there's this other piece right next to solving for A and B. We're going to cut that piece off as well. All right. So once you've done all this, you're simply going to take the title page, the Pythagorean theorem, and you're going to fold it down here where it says solving for A or B, like so, okay? And then you're going to take this other piece and you're going to fold it where it has solving for C. Oh, we've got two more things we need to cut off. So we're going to cut this off here. And this off here. All right. So now we're going to line that up with the vocabulary and the solving for C, like so. And then I'm going to take where it says example 3 about Zachary, and I'm just going to stick that inside, like this. And now you have your flip book. So you should start with, when you open it up, you should have, oh, that's not right. You're actually going to flip it this way. Vocabulary comes first. So you should have example 1, example 2, example 3, that's folded this way. You have your Pythagorean theorem there. And then you put that inside. You have 1, 2, 3. And then you have 4, 5, 6. And then that's it. And then you're going to go ahead and just staple your edges here. If you don't have a stapler at home, you can staple it when you get to class tomorrow, and then we'll put them in our notebooks. So that's that. So let's go ahead and get started with the Pythagorean theorem. So we'll blow this up a little bit so we can see better. All right, so let's start first with our first page. We have a triangle here, and this is a special type of triangle. This is a right triangle. It's a right triangle because it has exactly one right angle, okay? And on the right triangle, we're going to have three different parts, two of which are the same. This is a leg, the leg of a triangle. This is the leg of a triangle. And the side that's across from the hypotenuse, okay, across from the right angle, that side there is called the hypotenuse. And that's what we're going to be able to find the value of using the Pythagorean theorem for the first few examples. So this is one leg. We'll label that A. This leg we'll label B, and the hypotenuse we're going to label C. So the legs, we usually start with the shortest being A, the second shortest being B, and the longest being C. If we don't know the length of the legs, it doesn't matter whether we use A or B, but the longest side is always going to be C for the hypotenuse. So the hypotenuse is the longest side of a right triangle. All right, so these are our two shorter sides, and the hypotenuse, of course, is the longest side of a right triangle. And we're going to label that with C. All right, so now that brings us to Pythagorean theorem. This should look familiar from what we did in class today. You can see that we have three squares and they're surrounding a triangle, just like we did in class. And we found that when we have a squared plus b squared, and that's equal to c squared, that forms a right triangle. And we know it's a right triangle because of that square there that's in the corner. Okay, so if we look at A here, this is A, this is B, and this is C. Okay, so A squared is 9. And B squared, if we look at our area of our square, is 4 by 4. So that's going to be 16. And then if we put those two areas together, they make up C squared, which is the area right here, which is 25. So that's our Pythagorean theorem. That's what we're going to use to find missing side lengths of triangles. So again, this is, although the side length is 9, the side length is 3, the square is actually going to be 9. The side length here is 4, okay, but the square is 16, and this is 3, and this is 5. Okay, so basically another way of saying this is 3 squared plus 4 squared equals 5 squared, and we can prove it up there. So you'll see how this theorem will help us come up with missing side lengths of triangles. So let's go ahead, and now that we're done with the vocabulary part, let's go on and look at how we can use the Pythagorean theorem to solve for C. So I have two examples here, example 1 and example 2, and I'm going to find the unknown side lengths. So I'm going to write down my formula, my Pythagorean theorem, which is a squared plus b squared equals c squared. And I'm going to plug in what I know. I don't know c. I know that a is equal to 5, b is equal to 12, because those are my two legs. So I'm going to plug in for a, 5 squared, for b, 12 squared, and that should give me c squared. I'm going to go ahead and evaluate the exponents. So 5 squared is 25, plus 12 squared is 144, and that should give me c squared. And you're going to see we're going to be able to use this to come up with the value for not only c squared but for c. So I'm going to add 25 and 144 together. I get 169 equals c squared. But that doesn't mean that our side length here is 169. It means that the square formed from c would be 169. So to find the answer to this, we're going to simply find the square root of both sides. So I'm going to find the square root of c squared, which gives me c, and then the square root of 169, which is 13. So the answer to this question, c, is going to be equal to 13. All right, let's go ahead and try example number 2. Same thing, we're going to start with our Pythagorean theorem. We're always going to write it down. So our Pythagorean theorem is a squared plus b squared equals c squared. A and b are both 8, and then c we don't know yet. We're going to have to use the theorem to find it. So if a is 8, we're going to plug it in here. 8 squared plus 8 squared equals c squared. 8 squared, of course, is 64. 8 squared again is 64, and that is c squared. If we add those together, we get 128 is equal to c squared. Again, this side length is not 128. That's way too long. We need to instead find the square root of both sides to solve the equation. So I use for this one, it's not a perfect square, so I'm going to use my calculator. And I'm going to take 128, and I'm going to find the square root, and I get 11.3 if I round to the nearest tenth. So that means c is equal to 11.3 approximately. So C is equal to 11.3. All right, so that's what you do when you have missing hypotenuse. When you have C that's missing, you simply apply the Pythagorean theorem. You plug in a squared and b squared. You add that value together, and then you find the square root of both sides. Let's go ahead and take a look at a word problem. Example 3. Jane and Zachary start walking at the same point, but Zachary walks 5 feet north while Jane walks 75 feet east. How far apart are Jane and Zachary when they stop? Okay, so for this we're going to draw a picture. When you have word problems, I'd like you to draw a picture. So if they're starting at the same point, I'm going to draw a dot to represent the point. And Zachary walks 5 feet north, so this is going to be Zachary. And Jane is going to walk, let's see, this is 5 feet north. I'm going to label that 5 feet. And Jane walks 75 feet east. So this is going to be 75 feet east, going to the right. And it says, how far apart are Jane and Zachary when they stop? So we're going to assume that Zachary is here and Jane is here. So we're going to draw a straight line connecting those points. And you can see that this forms a right triangle. Okay, so make sure you get your picture drawn. So this is Jane going east, and this is Zachary going north. And now we're going to apply that theorem. A squared plus b squared equals c squared. And a is going to be equal to 5, b is equal to 75, and c is our unknown value. So we're going to plug in a, 5 squared plus 75 squared equals c squared. 5 squared, of course, is 25. 75 squared, I'm going to use my calculator for that, plus 5,625 equals c squared. I'm going to add a squared and b squared together, and I get 5,650 equals c squared. And that doesn't mean that's how far they are apart, that's c squared. So you're going to then find the square root of both sides. I have my calculator, 5,650. I'm going to use my square root key, and I get approximately, I'm going to round this to the nearest tenth, 75.2 feet. So they are 75.2 feet apart. So there's my answer. And so C is equal to 75.2 feet. All right, so now we've seen a couple of examples of how you find the hypotenuse. Now we're going to look at a couple of examples where you're going to find the legs when given this hypotenuse. So we're going to pull up this tab, solving for C, and we're going to go on to look at how we solve for A or B. All right, so I'm going to pull this down, example 4. Okay, so this time I know A. This we're going to label B, and this, because it's the longest side, we're going to label that C. So they tell us that this is A, and we know that C is 7 because, again, the hypotenuse is across from your right angle. All right, so we're going to apply our formula. A squared plus b squared equals c squared. A, we don't know. B is 3 squared. And then C is 7 squared. So we're just going to plug in our numbers. All right, and so we're going to simplify what we can. A squared plus 9 equals 49. And now notice we have our variable over here. What we're going to do is we're going to subtract. We're trying to isolate our variable. So we're going to subtract 9 from both sides. So this cancels out, additive inverse property. And a squared equals 40. So again, our leg length is not 40. That's the square of our leg length. So we're going to find the square root of 40 using our calculator. I know it's between 6 and 7, but the square root of 40 is 6.3. So A is equal to 6.3. 0.3. All right, let's go ahead and try example 5. Again, same formula, but I'm going to go ahead and label first so I don't get confused. B, this has to be A, again, because C is always going to be across from your right angle, so A must be 7. And our theorem is A squared plus B squared equals C squared. I do need you guys to write that down each time just to make sure you're doing everything correctly. A squared is 7 squared, B squared is unknown, and C squared is 25 squared. So I'm going to simplify here anything that I can, evaluate my exponents. 7 squared is 49 plus B squared, and then 25 squared I believe is 625. All right, I'm going to isolate my variable. B's over here, so I'm going to subtract 49 from both sides. So this cancels out our additive inverse property. B squared equals 576. But again, we're not done. This is telling us B squared. The square of that side is 576. I want to know the actual side length, so I'm going to find the square root of both sides. I'm going to find the square root on my calculator of 576, and that answer is a nice even 24. So that side length is equal to 24. Okay, so it's just like the other finding C, but now to get A or B, we just have to subtract before we find the square root. Instead of adding, we subtract. All right, let's take a look at the last example. Bobby leans a 15-foot ladder against his house. The base of the ladder is placed 4 feet from the base of the house. How far up the house does the ladder reach? Okay, so we know, again, we're going to draw a picture that he's leaning a 15-foot ladder against his house. So I'm going to draw a leaning ladder, okay? And I'm going to label it 15 feet. You need to draw a picture for these. So the 15 feet is the ladder against the house, and of course our house is going to be a straight line forming a 90-degree angle with the ground. Okay, so this is our house here, and this is our ladder. And so let's see what information it gives us. And we could even draw like a little ladder there to illustrate that's what it is. The base of the ladder is 4 feet from the base of the house. How far up the house does the ladder reach? Okay, so I'm going to go ahead and label this B, because you notice our ladder is going to be the distance from across the hypotenuse. So that means our C value is equal to 15 feet. Our B value is the distance how far up the house, that's B, and then 4 feet from the base, that's our A value. Okay, so now we have everything we need to apply the theorem. So again, we're going to use A squared plus B squared equals C squared. A is 4. B, we don't know. C, we know is 15, and we're going to square that to get C squared. So I'm going to evaluate my exponents. 4 squared is 16 plus B squared, and 15 squared is 225. That's one of our perfect squares we should know. Okay, so now that we've set it up, I'm trying to isolate my variable. So I'm going to subtract 16 from both sides. So B squared is equal to 16. Excuse me. B squared is equal to 225 minus 16. So I get B squared is equal to 209. All right. So I'm going to find the square root of both sides, and B, or the distance from the bottom of the house to the top, is going to be equal to approximately 14.5 feet. All right. We have several examples that we looked at that we applied together. Be prepared with your notes in class. You're going to have several examples to do on your own and with your groups tomorrow. Have a great day.